Hello, my name is Tina, and I'm a recent graduate of New York University, Abu Dhabi. Today, I will be presenting our paper titled Towards Automatic Narrative Coherence Prediction. Our day-to-day lives are surrounded by narratives. These are the stories that we tell to our family members and friends. How one recalls a specific event and also the manner in which it is narrated reveals a lot about how the narrator feels about the event and the extent to which they are affected by it. So consequently, how we recall our own experiences reveals a lot about our individual characteristics and also about our mental well-being. The narrative coherence coding scheme was established to exploit these exact features of our narrative recollection for research purposes. So narrative coherence coding scheme is a set of guidelines established in psychology research that annotates the coherence of a narrative, so a specific piece of text, along the three dimensions: context, chronology, and theme. Each narrative is given a discrete score from 0 to 3 for each of the three dimensions present in this coding scheme. Context evaluates the text based on the specifics of the time and the place of the event. So, for example, in the sentence, I studied abroad in Paris during the fall of 2018, the important pieces of information to measure the coherence on the dimension of context are Paris, the place where the event happened, and fall of 2018, the time when the event happened. Chronology evaluates how well established the chronological consistency is within the entire narrative. We can look at the following example. I returned home at 3 p.m. For an hour, I lay in bed, after which I ate lunch. We can see that there's sort of a chronological sequence in which actions happen in this example. First, I returned home, then I lay in bed, and after that, I ate lunch. This is what determines the coherence on the dimension of chronology. And lastly, theme focuses on how well the text follows its main plot and whether there is a resolution at the end of it. Let's look at the following example. Even though I failed, the experience taught me a lot. I look back on it fondly. We can see that there's a certain resolution to the event. The narrator learns something from the experience, as they mentioned that they look back on it fondly, and this is what really determines the coherence on the dimension of theme. So narratives, as mentioned, are without a doubt an important element of research in psychology. But why did we decide on looking at the narrative coherence coding scheme specifically? A significant correlation was found between a narrative's coherence score and independently collected mental health markers of the narrator. Currently, all of the coherence annotations are done manually, and as you can imagine, that is a very time-consuming task that drains vital resources that could be used elsewhere. So the main motivation behind our work is to explore ways in which we can advance and streamline the research of mental health disorders. Research on the prediction of narrative coherence scoring along these three dimensions mentioned before, so context, chronology, and theme, is actually very limited. And it also usually focuses on looking at each of those dimensions separately and not in the specific context of narrative coherence coding scheme, but rather just as a feature of text. For example, context would be looked at in the context of classification of specific textual context. Then chronology would be looked at mostly in terms of temporal relations. So how and what sequence do actions follow in a specific text? And then theme would mostly be looked at in the context of topic classification. So in this work, we propose a natural language processing based approach to predict the narrative coherence score along these three dimensions. And we formulate it as a full-class classification problem. To develop this approach, we firstly collect the narrative coherence corpus, which includes 1,375 narratives collected at the two universities, New York University and Western Washington University. Participants were asked to narrate events in their life in 5 different categories. So they basically responded to 5 different prompts. And each of the prompts was either asking a participant to describe a positive or a negative event. Alongside these narratives, our corpus also includes several independently collected mental health markers the following ones: state trait anxiety inventory, Beck depression inventory, and dissociative experience scale. All of the narratives, so all the 1,300 some narratives, were marked on the 3 dimensions separately. So there would be a score for context, a score for chronology, and a score for theme. Score 0 for any of them would indicate that there are no significant markers present to determine the coherence in the narrative, whereas score 3 would represent a meaningful amount of information. For example, score 0 for context would indicate that there is no information whatsoever about the time and the place of the event, where score 3 would mean that there is tangible and specific information available. We can look at how this plays out in the following example. So this narrative has been marked with a score 3 on all 3 of the dimensions. The context is marked as a 3 because we can see that there's very specific information about the time and the place of the event if we look at the text highlighted in blue. Chronology was marked as a 3 because if we look at the subscript time order indicators, we can see that all of the actions are ordered in a chronological sequence. So they follow each other in a very senseless manner. And then theme is marked as 3 because this narrative is one topically consistent. And if we look at the last sentence, we can also see that it has a very clear resolution at the end of it. To study the correlation between the coherence scores and the mental health markers, we perform canonical correlation analysis between the set of collected psychological scales mentioned before and the set of coherence scores for different dimensions. Specifically, we study the correlation with the coherence of the negative and positive coherence events. The table here shows the results of the CCA, the correlation analysis. As you can see, there is a positive correlation between the 2 sets for all the dimensions for both positive and negative events. This correlation even increases to 0.337 between all the narrative scores and then the psychological skills, which is a moderately high correlation. So we propose to use 2 different approaches to predict these coherence scores. The first one is the traditional machine learning approach, and the second one is transfer learning approach. Additionally, we also propose to look into how different parts of the text influence the predictions. So we train the different models on different parts of the narratives, either the first part of the narrative, the second half, or the entire text, to see how then the prediction scores would differ for different dimensions. As we've seen so far, the 3 dimensions are very different in what they measure, so we hypothesized that the scores for each would depend. Results of the prediction tasks overall were better on BERT than they were on the traditional machine learning models. For context, the best traditional machine learning model was the SVM with lemmatized text and with stop words kept. It achieved a 53.6% accuracy on the full text. On BERT, we had a slight improvement in accuracy with a 53.7% accuracy score on the first half of the text, as opposed to the full text in the traditional machine learning model. For chronology, the best performing traditional machine learning model was again the SVM, but in this case, with a part of speech tag text and with stop words kept. It achieved a 69.6% accuracy on the last half of the text. As opposed to that, the BERT actually achieved the best accuracy on the full text, achieving a 71.8% accuracy. For theme, the best performing traditional machine learning model was yet again the SVM, with, similar to chronology, a part of speech tag text and with stop words kept. It achieved a 65.4% accuracy on the last half. In this case, BERT and traditional machine learning models achieved the best scores on the same part of text. So BERT also gave us the best result on the last half of the narratives with a 69.6% accuracy. So in conclusion, for traditional models, optimal performance really depends on the varied pre-processing techniques. We saw that the context performed better on text that was lemmatized, whereas chronology and theme achieved better accuracy with a text that was stacked for part of speech. And all 3 dimensions benefited from keeping stop words. So we can really see that each dimensions require a separate and modified approach to be able to predict these coherence scores. In all three dimensions, BERT outperformed our traditional machine learning models. And BERT also confirmed our hypothesis that different parts of the narrative achieve higher or lower accuracy scores for each dimensions. So we could see that, for example, chronology, the accuracy using BERT was much better when we used the entire narrative, whereas when we used either of the halves. For context, it performed better on the second half, and for context, it performed better on the first half. As for our future work, we propose to study the effects of gender and other demographic markers on coherence score prediction. We also propose to take a step further and explore prediction of actual mental health markers from the coherence scores or directly from the narrative text, and not to stop just at the coherence scores. We also propose to acquire more narratives to ensure equal distribution across the 4 possible scores of each dimension. Thank you. Results of the prediction task were better on BERT than on the traditional machine learning models overall. For context, the best performing traditional machine learning model was the SVM, with the text preprocessed through lemmatization and stop words kept. It achieved a 53.6% accuracy on the entire narrative. As opposed to that, BERT actually performed best on only the first half of the text, achieving a slight improvement in accuracy of 53.7%. For chronology, SVM was again the best model, but this time the text was tagged for part of speech and stop words were kept. It achieved a 69.6% accuracy on the last half of the text. Again, as opposed to that, BERT actually performed better on a different part of the text, this time on the entire text, achieving a 71.8% accuracy. For theme, SVM again was the best performing model, and similarly to chronology, the text was tagged for part of speech and stop words were kept. This time, the model performed best on the last half, achieving 65.4% accuracy. BERT results actually agreed with the traditional machine learning models in terms of what part of the text was used. So again, last half, and BERT achieved a 4% improvement over the traditional machine learning models, achieving a 69.6% accuracy. So in conclusion, for traditional machine learning models, we can really see that the optimal performance depends on the varied preprocessing techniques. The coherence prediction for context were better using the lemmatized text, versus the prediction for chronology and theme were better using the part of speech tag test. Although all 3 dimensions benefited from keeping the stop words as opposed to removing them. This really confirms that each of these 3 dimensions requires a separate approach to predict the coherence score. As mentioned before, overall, BERT outperformed traditional machine learning models on all 3 of the dimensions. And BERT also confirms our hypothesis that different parts of the narrative achieve a higher or a lower accuracy score for each of the dimensions. So we saw that for context, the best performance was achieved on the first half of the text. For chronology, it was the entire text. And then for theme, it was on the second half of the text. For future work, we propose to study the effects of gender and other demographic markers on the coherence score prediction. We also propose to explore the prediction of actual mental health markers, either from the coherence scores or directly from the narrative text. And lastly, we also propose to acquire more narratives to ensure equal distribution across the 4 possible scores for each of the dimensions. Thank you.